Okay, so for lesson 2, we're going to investigate between two categorical variables. I believe in lesson 3 we'll talk about those that are categorical and numerical. But just for the point of this lesson, we're investigating those with only two categorical variables. If we see that two variables are related or linked in some way, we say that they are associated. Okay, that's the official word that we use in general maths. They have like a relationship. To begin the investigation of an association between two categorical variables, we create a contingency table, or what's better known as a two-way frequency table. Two-way frequency table. So let's look at an example. It has been suggested that city and country people have different views on gun control. That is, the support for gun control depends where a person lives. How we might investigate this relationship is what we're going to do today. So the first thing to note is that these two variables are both categorical variables. And they are usually represented in the form of a frequency table. A frequency table looking something like this. Okay, so those who live in the country, there is 58 of them. Those who live in the city, there's 42 of them. In total, we have 100 people, just like here. Okay, but then we asked the same 100 people a question again, and we said that 62 of them were for gun control and 38 against gun control. More specifically, we've got the breakdown here. Okay, so 32 people are for gun control that live in the country. 26 that live in the country are against, and so on. The rest is here. So before we set up the two-way frequency table, we need to decide which is the explanatory and which is the response. Okay, so which one would explain which? So in this question here, it's suggested that city and country people have differing views. So we're going to say that based on where they live determines what their opinion is. That's what we're trying to investigate. Okay, so we're going to say, since we think that a person's attitude to gun control might depend on their place of residence, but not the other way around, then we're going to say that the residence is the explanatory variable. Okay, which we often call EV, and the other one, which is the actual attitude to gun control, being the response variable, RV. So in two-way frequency tables, it's common to let the categories of the response variable label the rows. Okay, so let's highlight that. The response variable in rows, and the categories of the explanatory variable label the columns. So the columns for the explanatory variable. And as you can see here in this table below, we've got the rows are the response variable. Okay, so the rows are for and against, and the columns are the explanatory variable. Okay, so explanatory variable is for residence, and the response variable is for the attitude to gun control. Okay, so always make sure that columns, and sometimes I get confused which one's columns and rows, but columns are the ones that goes up and down, so these ones, and rows are the ones that goes across. So let's get into an example. Something completely different now. The following data was obtained when a sample of 10 Year 9 students were asked if they intended to go to university. The gender of the student was also recorded. Create a two-way table from this frequency, from this data. Okay, so here's all the 10 students. A female said yes, a male said yes, a female said no, and so on. It is possible that a student's intention to go to university may depend on their gender. Okay, but not the other way around. We can't really say that their intention to go to university will dictate whether or not they're male or female. Okay, so it's usually the gender that dictates whether or not they'd like to go to university. But we're just going to investigate to see if there is an association or if there is a relationship. There might not be. So thus, the gender is the explanatory variable. This is what we're trying to see might explain whether or not they go to university. And so therefore, going to university is the response variable. Okay, you can put EV and RV if you want there. Okay, so here we go. All right, so what we've done now to break this down, gender is the explanatory variable, and that's why it's here. And they're the two columns. Okay, so the explanatory variables should be the two columns. And therefore, whether or not they go to university are the two rows. Okay, so essentially what they've done here is how many are male and said yes. Okay, so how many are male and have said yes? There's one here and there's one here. So there's only two of them there. How many are male and said no? So male no, male no. And for the other two as well, you can see that there are 4 females who said yes and 2 females who said no. It's really important to note what's going on the outside here. Okay, you've probably seen this before. But essentially what you're going to do is, once you get these middle 4 numbers here, you're just going to add this way to get to the 6, add this way to get to the 4, and add this way to get down to the 6, and this way to get down to the 4. And hopefully, if you've done everything correct, 4 plus 6 equals 10, and 6 plus 4 equals 10. Okay, so we're going to do an example like that, hopefully, on the next page. Looking at the table below, so going back to the gun control question, we can say that more country people are in favor of gun control. So this is once we did that table from this same table here, from that previous example, we can see that more country people are in favor of gun control. So let's see what that means. For gun control, slightly more people are in the country than in the city. Okay, but this is just due to the fact that there are more people living in the country than living in the city. So if you look here, okay, we've got 58 people who live in the country and 42 people live in the city. So the only reason why we've got more people in the country who are for gun control is because, well, there's more of them to begin with. Okay, so really, it doesn't really tell us anything. Okay, so this is just due to the fact that there's more people living in the country than in the city. So we actually want to answer the question to see if there is a relationship, but to do that, we need to create a percentage two-way frequency table, percentage being the most important part. Okay, so it is common for a two-way frequency table to have the categories of the response variable label the rows and the categories of the explanatory variable label the columns. So let's do that again. Let's highlight in the right colors. Just want to see which colors I use. Give me a second. Yellow was for response. So yellow was for response, which was rows, and green was for columns, which is explanatory. So it's still the same thing, okay? Still the same rules apply, but just now we're dealing with percentages. So therefore, in order to create a percentage two-way frequency table, it is common to calculate the column percentages. This is the most important part of this table here, column percentages. You'll see what I mean in a second. So I want to work out, we know that the country people, there was 58 people, and for the city, there was 42. Okay, so how many of these country people were for gun control? If you go back, you'll see that there was 32 of them. Okay, so 32 people out of the 58 were for gun control. So we're going to turn this into a percentage by multiplying it by 100. And that should get you 55.2%. From country, still, how many were against? Let's go back up and check. 26 were against gun control. So 26 out of 58. Okay, and that's going to give us a percentage of 44.8. Which means for the total people, 58 out of 58 times 100, that should give us a total of 100%. Now what we're going to do, we're going to do the same thing, but for the city. Okay, so how many of them were for gun control that lived in the city? That would be 30. So 30 out of the city people, which is 42. Okay, and that gives us a total percentage of 71.4%. How many were against? There was 12 that were against it, that lived in the city. 12 out of the 42 that lived in the city were against it. So 28.6%. Okay, so for the last one total, 42 out of 42 people should give us 100%. So now we've got more information to read and more of an idea what's going on. Okay, it looks like from the previous example up here that more people in the country were for than the city, but we realized because the country people, there's more of them, that's why there's a bigger number. So we more care about the percentages. So out of the country people, 55.2% are for it and 44.8% are against it, whereas in the city, it's much more obvious that the city people, 71.4% are for it, whereas 28.6% are against it. Okay, so this is summarized nice and neatly here. From the table, we see that 55.2% of the country people are in the sample were for gun control compared to 71.4%, similar to what I just said before. All right, so we're comparing those two numbers there. This reverses what the frequency showed. So the frequency showed before that 32, two more people were for it than the city people. But again, I've said it like 3 times now, it's because of the number of people living in each section. So thus we can say that the variable's attitude to gun control and residence are associated. Okay, we can see if the variable's attitude to gun control and residence were not associated, we would expect approximately the same percentages of country people and city people to be for gun control. But we can see that these two numbers here are pretty different. You know, we've got 55% and 71%. So it is for us to say that these two variables are associated. Okay, that's the key word here, associated. Should highlight that one. So to write the report, we say in this sample of 100 people, a higher percentage of city people were for gun control than country people, 71.4 compared to 55.2. This indicates that a person's attitude to gun control is associated with their place of residence. So to get to this, we're going to, you don't have to write anything, but we're going to talk about it again. So report the findings of the table below. So what do we have here? We have year level, and we have should mobile phones be banned in cinemas. So we're going to ask a bunch of year 10s whether they think phones should be banned in cinemas, and we're going to ask a bunch of year 12s the same question. So the reason we know that this is the explanatory variable and that this is the response variable is because the year level goes in columns. So therefore that must be explanatory variable. And the response variable, which is the yes or the no, goes in rows. So in this sample of 100 year 10 and year 12 students, we see that the percentage of year 10 and year 12 students in support of banning mobile phones in cinemas is similar. Okay, we can see that these two numbers are quite the same. 87 compared to 86. This indicates that the person's support for banning mobile phones in cinemas is not associated. Not associated. with their year level. Alright, so what we want to do now is we want to go back to that same example with year 9s, and we're going to ask the question, are males and females in year 9 equally likely to indicate an intention to go to university? So here we've got the breakdown of the data. 50 male year 9 students said yes, 54 said yes from the females, and you can see the rest here. They're all totaled up. So what we want to do is we want to work out the percentages once more. We want to say, okay, well, how many males are there in total? There's 105. And how many, I'm just going to put in all the numbers. So we're going to put a 50 here, a 55 here, a 54 there, and a 41 there. Okay, and we're going to do our column percentages. So the males are out of 105. And then we're going to times them by 100. Okay, so for that one, we should get 47.6%. And for this one, we should get 52.4%. Okay, so the total number of females is 95. So put these out of 95. Times it by 100, and you should get 56.8% compared to 43.2%. Alright, this one here, because it's a percentage thing, we still have to do this. So you can just write 100% if you've added them up properly. Okay, so now we can see from the top row that a greater proportion of females than males were intending to go to university. So there is a difference between these two numbers. So what we're going to do is we're going to write a report. Okay, similar to the format of these reports up here, talk about how many people there are, what the two categories are, and then talk about sort of the top row. Okay, so just copying this down. In this sample of 200 year 9 students, a greater proportion of females than males, and then mention the percentages, 56.8% compared with 47.6% were intending to go to university, and then mention whether or not there's an association. So in this case, yes, there is an association between gender and intention to go to university. Alright, example 4. For the following percentage two-way table, so this is already put in percentages. Now we want to answer three more questions actually. Firstly, what is the explanatory variable? Is it age group or is it interest in sport? Now remembering the one that goes downwards, okay, so the ages here are the explanatory variable. EV equals age. We can write a report based on these percentages. So let's have a look at this report here and let's see. We tend to just sort of look at one row, and if we see a difference, then we can comment on it. So what I notice here is that for the high interest in sport, it's declining, okay? It's declining. So as you get older, the interest in sport goes down, okay? Which means I would actually expect that this would get bigger. And it seems like that's what's actually happening. Okay, so low interest in sport would get bigger as you get older, and high interest would decrease as you get older. So you can say that there is an association, and I'll just get you to copy this down. This should be yep, there is an association between the level of interest and sport, interest in sport and age. A high level of interest is seen to decrease steadily across the age categories from 56.5% for under 18, and just slowly mention them all. And then it gets to its lowest at 35% for 36 to 50. So I'll keep that there. You can pause me if you want to copy that down. Okay, and once we've done part B, let's move on to part C. So this is, I'm just going to put it there for you guys to copy, but I want you to have a look at how this has been done. Okay, so step 1, since age group is the explanatory variable, we'll label the horizontal axis. Okay, and age group goes down here, and then we just broke it down into the 4 age groups that we have. The vertical axis is interest in sport, so therefore because this is a segmented bar chart, we're going to do percentages. So it should go from 0 to 100. Depending on how you go, I always sort of recommend going up by tens. It's nice and easy to see that, and that's usually how they look. So there will be a bar for each value of age group. So 1 for under 18s, 1 for 19 to 25, 1 for 26 to 35, and 1 for 36 to 50. Mark off and color with each value of interest in sport assigned to the same color. So then just sort of making sure that you start with the same one at the bottom, high, as high as you need to go. And then for the middle one, medium, make sure that in this case, under 18, this bar here, that it actually represents the percentage that you need. So under 18 medium is 30%, 30.1%. So as you can see from here, which is, let's say, meant to be 50.2%. So for under 18, it's actually 56.5% here. So we want another 30 to go up. So 56.5, add another 30, should be 86.5. And that's how we've got up to there. And then for the next one, which was low, it is 13.4. So that sort of takes you up to the rest there. So just having a look at this bar chart, marking off and coloring, and then adding a key at the end to say it, so that way you know which color associates with which. Thank you very much, and good luck on the questions.